As promised, we saved F for this next video. The next few, F through L, will all be done on this video. And instead of the equation involving addition or subtraction, these equations involve multiplication or division. So we're going to, again, solve them by applying the opposite operation and finding the solution. So, in this first one, since 4x means 4 times x, we're going to undo that by dividing both sides by what's being multiplied to dx, which in this case is 4. And the property illustrated in that one, since we're dividing both sides by the same thing, the property that's illustrated is the division property of equality. Okay? And again, just like in the previous video, symbols and abbreviations are just fine. So then when we divide both sides by that 4, x cancels, and 6.4 divided by 4 is 1.6. And again, you can check by checking to see, is 4 times 1.6 actually 6.4? And if you use your calculator, you would find that it is. 4 plus 2.4 is 6.4. Ha! Mental math from the distributive property that we talked about last week. So x is 1.6 is in fact the solution. Now for g, this time we are dividing by 15 to get the x by itself. And since we're dividing both sides by the same number, again, that's the division property of equality. So now, in solving this, we end up with x is equal to, since 15 does not go evenly into 10, we're going to end up with a fraction or a decimal. Personally, I prefer fractions because they're a little bit more precise, a little bit easier to check. If we have 10/15ths, now we see if we can simplify that fraction. And 10 and 15 both have a common factor of 5. So we're going to divide both of those by 5. 5 goes into 10 twice. 5 goes into 15 3 times. So that's equal to x. And again, we can check that. Is 10 equal to 15 times 2/3? And again, like mentioned before, when multiplying a whole number to a fraction, only multiply it by the numerator. So we have 30/3. 15 times 2 is 30/3. And 30 divided by 3 is in fact equal to 10. So we know that that is our solution. Now, a lot of people ask, are decimals okay? Yes, but you need to be precise. If you put 2/3 or even 10 divided by 15 into your calculator, you would get a bunch of 6's, and at the end there would be a 7. Well, what that represents is 0.6 repeating. If you have a decimal in your answer, and on a quiz or a test, if you write your answers in decimals, make sure that you are precise and you have the repeating bar if you need it. If you have 0.67 in your round, you will not get full credit for that. So you need to be precise. Now in h, we have negative 3.2 times a z, so we're going to divide both sides by that negative 3.2. And again, since we're dividing the same thing on both sides, that is in fact the division property of equality, and you are justifying your work. You are justifying what you are doing there. So then, in this case, we have z is equal to 14 over negative 3.2. Now in this case, if we leave this as a fraction, decimals and fractions are not okay. So I want to get rid of that fraction by multiplying both the top and the bottom by 10. We're going to move each decimal point over one place. And that becomes 140 over 32. Negative. And then I look to reduce that fraction. Now again, a lot of my answers are going to be in fractions. If you write them in decimals, make sure you are precise. Well, they're both even, so I know that 2 is a common factor. 2 goes into 140 70 times. 2 goes into 32 16 times. Once again, 2 is a common factor. 2 goes into 70 35 times. 2 goes into 16 8 times. So there's a solution for z. So based on this, if you wrote this as a decimal, it probably comes out to negative 4 and 3/8. So that would be 0.375, being precise. On the next two examples, now we are dividing a variable by a certain number. So to undo division, again, you think opposite operation. We're going to multiply everything by 4. Okay? And as you guessed it, justification, multiplication, property of equality. So over here, the 4's cancel, so we're left with just x. And 4 times negative 9 gives negative 36. And again, you can check, is negative 36 divided by 4 negative 9? Yes. So we know we did it correctly. In the example J, 3 is being divided into the r, so we're going to multiply both sides by 3 to undo that. And since we're multiplying both sides by the same number, once again, that is the multiplication property of equality. And to multiply both sides by 3, 3 times 19 is 57. 3 times 10 is 30. 3 times 9 is 27. Add the two together to get 57. It's equal to, over here, the 3's cancel. So r is equal to 57. You've got a couple more to go. Now these are interesting. These involve multiplication. So we would divide both sides to solve for the m, but they're multiplying by fractions. So to think about this, to get the m by itself, we would divide both sides by 4/5. Well, dividing by a fraction is the same thing as multiplying by its reciprocal. So the reciprocal of 4/5 involves just flipping the 4/5. So we would, in fact, multiply by 5/4. So again, we would have the multiplication property of equality. And again, the reason we multiply by 5/4 is we would divide by 4/5, but dividing by a fraction is the same thing as multiplying by its reciprocal. So, multiplying everything by 5/4, the left side, 5/4 and 4/5 cancel, so we're left with just m. 28 times 5/4, and once again, you can multiply it to the numerator and then reduce, or you can look to cancel. Some of you have learned this. You can look to cancel the 4 and the 28. Well, 4 goes into 28 7 times, so that becomes 7 times 5, which is 35 for your result. Okay. If you multiply 28 by 5, well, that is 140. Now, one thing you might see is, okay, both of those are even, so common factor of 2, so we have 70 over 2 another common factor of 2 to get to 35. Either way works. Follow your heart. Yeah, follow your heart. Now, in L, again, we'd be dividing by 3/4, which is the same thing as multiplying by 4/3. So 12 times 4 is 48, 48 over 3. 3 goes into both of those, so we have 16. Another way to think about that, 3 goes into 12 4 times. 4 times 4 is 16. And then on the right side, x equals 16. And once again, multiplication property of equality. In the next 2 videos, we are going to look at your favorite word problems.